Hi, everyone. Welcome to the June 2022 National Hydrologic Warning Council webinar. Following the webinar, the webinar will be recorded and we'll place it on our YouTube channel. Today we have Jamie Rhome with us, Director of the National Hurricane Center, and he will be giving an update on the 2022 hurricane season. So thank you, Jamie. I'm really looking forward to your talk. I'm originally from Louisiana. Now I'm out in California. So should be interesting. If you have any questions during the presentation, please use the questions function for the webinar, and I'll read those out for Jamie. So Jamie, I'll let you take it from here.
Hey, thank you, everyone. Where is the share screen? Oh, here it is. You gave it to me. As soon as I get this up on the, so can you see my screen yet?
Yes, looking at your desktop.
All right. Does that look about right?
Yeah, now I see your PowerPoint.
And is it in like full screen, or are you seeing a partial screen?
I'm seeing the slide deck and the current slide.
Okay, let me get it in. I've got a dual screen here. That sometimes throws it off. I've got a dual screen, and it is, we might just limp along like this. The dual screen appears to be throwing it off. But can you see okay?
Yes.
Well, it's a pleasure to be with you all today on it's sort of an apropos day, seeing as we've got the disturbance sitting right off the coast of Texas today. And we won't be talking about that so much as trying to talk about where we are with respect to the 2022 season and any sort of lessons that we've learned from the last couple of seasons. And I just sort of came up with a flippant title here because I kind of sense this is where everybody is with respect to hurricane seasons. It's sort of like, well, now what? It seems like the last couple of years have thrown everything but the kitchen sink at us, and people are probably thinking, oh my goodness, what could possibly be in store for the 2022 season. So if we look back over the last couple of seasons, if you came away from the last few hurricane seasons thinking it was busy, you'd be right. It's an extraordinarily busy string of 4 years. Here's just some statistics. There are many statistics we could rattle off, but for the purposes of not overwhelming people, just sort of plucked off some of the top line stats here. 100 named storms, 45 of which were hurricanes, and 21 were major hurricanes within that span of 2017 to 2021. 16, and let me give you context, because I think it's easy to be numb after the pandemic and the last few years. Our forecasters got more experience the last 4 years than some of the previous generation hurricane forecasters got in 40 years. So literally our crew, which is young, forced to grow up pretty quickly with respect to experience with landfalling hurricanes. 16 hurricane landfalls, 7 of which were major hurricanes. That's a staggering number, especially for somebody like me who's been here for 23 years. I had thought that I had seen it all up until the last couple of seasons. Total direct tropical cyclone fatalities. Now, this is not just the United States, so that number looks big because it includes all of the international areas within our area of operations. So that's Latin America, portions of Central America, and then throughout the Caribbean. 1,000 fatalities, 1,000 direct fatalities. $320 billion is the last estimate that we have. That number tends to bounce around because it's really hard to do damage estimates. But I think the number there that's probably more static is $15 billion disasters and 7 $10 billion disasters. So, obviously, as we build more and more stuff in the path of hurricanes, these numbers are going to continue to creep up over time. And then for those of you who have known me over the years, this last paragraph is near and dear to my heart. I spent the last 12 years developing the nation's storm surge program in the new early warning system. Despite 16 hurricane landfalls, including 7 major hurricanes, there were only seven direct fatalities from storm surge. That's an unusually low number for storm surge direct fatalities. We can talk a bit more about that in a second in terms of what we think is contributing to that. But I think by and large, the storm surge warning system is working as it was intended. Now, let me just go ahead and deal with the elephant in the room, which is, good Lord, is all this activity due to climate change, and is it here to stay? So if you go back and look at the history of the number of cyclones over the last period of record, or what we think is a reliable period of record, there's a challenge here in that our detection systems, aka satellites and aircraft and buoys, and all the things that we use to see cyclones and detect cyclones and measure their intensity, we've gotten substantially better tools in our toolkit than say, just a mere 10, 15, 20 years ago. So our ability to detect cyclones has improved, which if you just look at the straight up numbers, gives you the impression that tropical cyclone count is increasing. But when you go back and correct the data set for so-called missed cyclones, you see that trend of increasing tropical cyclone threat increasing tropical cyclone numbers go away. And I'm going to be honest with you, people focus way too much on the cyclone numbers. That it's just a metric that people are far too obsessed about, not only in the seasonal forecast, but in this historical record. And those who advocate for or against climate change, this is not the metric to argue. And so I really want to convince you to get off focusing on cyclone numbers. It really is a misleading threat. The other thing I want to talk to you about here before we get in the meat of it is the pandemic really exposed the importance of another component of our mission at the Hurricane Center, which is our marine mission or protection of safety of life at sea. And how many of you tried to order something during the pandemic and you couldn't get it, or it was backlogged for 6 months, or it was stuck in a shipping container somewhere out in California because the global marine trade got completely taxed and overwhelmed, and we, for the first time in this country, realized how important our commerce is to the free flow of goods and services over the open ocean. And this is just if you look at some of the statistics here of how much of our economy, these are 2018 numbers, are 80% of all goods are carried by sea. I mean, I thought I had a good handle on this until I pulled the statistics. A shocking number, and a lot of that, a lot of those goods, a lot of that 80% flows through our area of responsibility here at the National Hurricane Center. I mean, look at the major ports in our area of responsibility: Houston, Galveston, Tampa, New Orleans, Miami, just to name a few. We also have the Panama Canal, which is a very popular route for ships moving about. It's just shocking. And then if you look at how the economic activity, marine economic activity, is going to grow over the next few years, this is an increasingly important component of what we do at the National Hurricane. So we don't just do hurricanes. I want to leave you with that. We also are in the business of forecasting weather and conditions at sea to enable the safe and hopefully efficient exchange of goods, which is increasingly important. Now, I talked about the elephant in the room, and I'm going to confront it head on. And I sort of tried to walk you away from looking at tropical cyclone numbers because I don't think that's the right way to look at it. You know, regardless of where you stand on the spectrum of what is causing climate change, it's absolutely happening and it's absolutely changing the nature of threats from hurricanes. So let's just suspend the notion that the number of hurricanes are changing, the frequency, the number, but I want to convince you that their impact is worsening, and it's primarily coming in the form of water. And you're living proof, given how many wet storms you get within your area and your expertise over there. So the three things that are contributing here, there is some indication that we're getting some slightly stronger storms, even if the numbers aren't going up. But the more important of the two here, the ones I really want to emphasize, is that sea level rise and the ability of a warm climate to hold more moisture. And all a hurricane is basically comes along and just squeezes the sponge. It squeezes all the moisture out of it. We're getting wetter and wetter storms. And you've seen it there. You've lived it there. And then specifically, if we dive into this, we're getting stronger storms, slightly stronger storms on the wind, but more importantly, wetter storms. That's really what I want to take home, is don't get bogged down in the tropical cyclone numbers. It really is not the best metric. All right, so with that, let's talk about what we have learned in all this hyperactivity and what we've learned from history to help us prepare for 2022 and prepare for storms that are going to pack an increasing punch or have a greater impact on us when they do occur. You know, this notion that hurricanes are going to march across the Atlantic for a week or two and give you tons of notice, that's just got to go away. That's just not happening for the strongest storms that have impacted the U.S. So if you go back and look at all the Category 5s that have hit the U.S., thankfully they're relatively rare, but if you look at the Category 5s that have hit the United States, they've all basically formed in situ or in place, meaning you had only 2 or 3 days notice. And so if your lead times are more than 3 days, if your hurricane plan takes more than 3 days, it's time to throw the book out and start over, because increasingly you're not going to get it. That's one of the things we're seeing in climate change, is the propensity of cyclones to rapidly intensify. And there's several examples from the past couple of seasons. Michael was a great example of a storm that rapidly intensified as it marched towards the Florida Panhandle. And even if we looked at, that was the Category 5s, but even if we took a more holistic view of storms, the top storms that have hit us, you get the same impression. So this is not just Category 5s, it's all of the stronger storms that have impacted the United States and basically have formed right at the coastline. And the reason for that is intense hurricanes are relatively fragile. Okay, that the dynamics required to create a very intense hurricane is very, very fragile, and basically it can't sustain itself for very, very long. So really the only way to get a super intense or very strong hurricane to hit land is for it to form very close to land. That's basically the premise behind it. And this is just some statistics to go with that. Of the 9 strongest hurricanes that have made landfall in continental United States, only 3 have become a tropical depression 5 days prior to landfall. 3 days prior to landfall, only 1 had reached hurricane strength. So you gotta just, this notion that you're gonna have tons and tons of lead time, I really wanna push people away from that. The average lead time here was 50 hours for the 9 strongest hurricanes. So think about that, 2 to 3 days, 2 to 3 days. The other thing we've seen in the last couple of seasons is this notion or this expectation that forecasts are perfect. And I wish I could say our forecasts were perfect, and I wish they were perfect. but they're not. They're still, despite considerable scientific strides over the last decade, there's still a fair bit of uncertainty in the forecast. And we're seeing people look at the literal edge of the cone or the literal edge of the wind radii and make highly deterministic decisions. Oh, I'm just outside the cone, I'm okay. Or, the cone just shifted, now I'm now outside of it. Or the hurricane wind barely touches me, I'm okay. You have to literally incorporate forecast uncertainty by moving the cone and the wind radii over. So we're just seeing this a lot with people. They have a saying for this in the South. I'm Southern. It's shaving the bologna too thin, or being too cute. And I'm going to 23 years of hurricane forecasting and surveying damage assessments after, and interviewing people after hurricanes. It isn't the time to be cute when you got a major storm barreling at you. You have to include uncertainty in your forecast, and people who don't pay for it dearly after the fact, because those decisions often burn them. This is another example here of, this was from Ida, where we shifted the track just to 15 miles. So the solid green line is the actual track. The dashed line is a synthetic or made up or hypothetical if Ida would have moved 15 miles farther to the east. And look how much it changes the amount of storm surge up against the West Bank over there. It's up to 7 feet of additional or more storm surge could have occurred if the system would have just wobbled 15 miles. And I'll tell you, 15 miles is not a hard right hook. That is a wobble in the grand scheme of things. And now I want to hit a little closer to home. The other thing we're seeing a lot of lately is everybody's a hurricane expert. The proliferation of information and models online. I can't tell you how many text messages we get or phone calls we get during storms from emergency managers asking us, did you see the European model? And I don't know how to respond other than, yeah, we do this for a living. Of course we see the models, but the way we see the models and the way we critique the models and the way we use the models is far more sophisticated than anything you might rummage through and find on the internet. Our ability to get more sophisticated information and extract things from that data set, I'm just going to call a spade a spade. You shouldn't be rummaging through the internet trying to be a forecaster, because like other aspects, you wouldn't have your next door neighbor perform open heart surgery on you. Why would you trust a random person on Facebook to give you guidance on something as significant as a major hurricane? And the models are wrong. And look at this example from a storm that hit close to home. You all remember this one. Here is the infamous Euro model and all of its ensemble members unanimously showing a direct almost impact for Houston and Galveston area. But the Hurricane Center, this is Laura, if you haven't figured it out, the Hurricane Center didn't buy into that. We had reason to believe that through past experience and our knowledge of the model, that had a west bias in this case, and we chose to make a forecast a little bit further east, and thankfully the good relationship with the emergency managers in that area, along with the Weather Service office, prevented what could have been massive evacuation in that area, which those of you who remember Rita remember the disaster of an evacuation that was, and we lost 104 people in just the evacuation alone in Rita. So, don't kneel before the altar of the models. I'm telling you, that it will burn you badly if you do so. And, you know, I'm not just saying that, I can back it up with science. So we've gone back and looked at how our forecast, meaning the forecast issued by a human, a real live expert at the Hurricane Center, that's a black dot on this, compares against the so-called models. So on the y-axis is the track error. So the further up the y-axis you go, the worse the forecast is. And on the x-axis is the consistency. So the further to the right is how wishy-washy you are, how much you jump around and change your mind. And what's interesting about this, so the red is the Euro, the green is UK Met, and the blue is the so-called American model. What's interesting about this statistic is the human forecasters at the Hurricane Center claim the clock of everything out there in both track and consistency, meaning not only are we more accurate, we're more consistent. We don't jump around as much as the global models do. And this is for 96 hours, but for thoroughness, I'm sorry, this was for 96 hours from 2017 to 2019, but for thoroughness, this is 2019 to 2021. And you can see a similar pattern unfolds, that we are both more accurate and more consistent. So if you call me up in a storm and say, hey, which model is best? It's just not a good question. We beat everybody hands down. The other thing that kind of surfaced out of the last busy season is words matter. Words matter, and we took the unenviable position of deeming the storm surge during Laura unsurvivable, and we meant it. We measured. We had several high water marks in the area that were in the 17 to 18 foot range. But more importantly, the storm surge rose at an astounding 10 feet over 1 hour, meaning that's almost tsunami-esque in its rise. A water rise of 10 feet in 1 hour is in my mind unsurvivable. And despite this 18-foot storm surge striking, one of the lowest lying areas, the western Gulf of Mexico, we have no reported storm surge fatalities from this storm. And even more shockingly, no reports of somebody being rescued. Normally, people stay behind, at least some proportion of the population stays behind, requiring some sort of rescue after the fact. There were no rescues in this particular storm. So that collectively implies a at or near 100% evacuation compliance for that particular storm. So when we use words like this, we really mean it. Now, yes,
we had a question on the previous slide.
Yeah, go ahead.
What is meant by track error? Slide 17, that is.
Track error is, if we say it's going to Texas, does it really go to Texas? How accurate is the track forecast?
Thanks.
Is that the only question? I don't have the little question thing open.
Yeah, that was it.
All right. Now, I talked about how storms are becoming more impactful, largely because they're becoming wetter and producing more impacts. So what are we doing at the National Hurricane Center to combat this? Well, we're turning increasingly to social science versus just strictly physical science. So social science is basically the study of how people hear and interpret information and how they make decisions and that sort of stuff. And so we've got several projects underway that there's looking at particular aspects of how to communicate risk from hurricanes and how our different constituents interpret risk. For example, there's this misperception amongst forecasters that among our forecasters, within the professional community, that people don't understand uncertainty information or probabilistic, and that has been scientifically debunked. If you look at the science of this, probabilistic forecast information is not only better understood, it's more actionable, that you get a better response when you present people with probabilistic information, or how certain you are. Meaning, if you're transparent and open with people about the potential outcomes and give them a full spectrum of the risk, they trust what you're telling them more, and they take better actions on it. So the notion that probabilistic information is too complicated for people, it has just been, debunked. There are other aspects of these projects that are ongoing. So we're looking at ways to improve our products at the Hurricane Center. We're looking at, do we need new products? Do we need to refine old products? Do we need to describe them differently? We're just basically looking at all aspects of how we communicate risk. The other thing we did during the pandemic is we built a hurricane and ocean test bed. We basically, if you've ever been to the Hurricane Center and seen our library, we basically repurposed that and turned it into a lab. And the lab is meant to be an incubator for new ideas, new research, new projects, to test things out. And not to put too fine a point on it, everybody and their brother thinks that they have invented the solution to hurricanes, or invented the next cone, or invented the next hurricane scale. And it's easy to sort of toss that stuff around and make those sorts of accusations. But in this case, we have a real live lab where we can test these things under the duress of a hurricane, meaning the timelines and demands of an actual hurricane, to determine which projects or which research endeavors are actually mature enough to be considered by the National Hurricane Center and the National Weather Service. We're really excited about this. We really think it's going to bring together the various disciplines involved in not only predicting hurricanes and their associated hazards, but communicating them in a way that ordinary people can understand and act upon. So we're really excited about it. This is the photographs of the new lab as we were starting to open it up. It's still a little bit of touch-up work to do, but it's largely operational. And that's kind of what we're gonna do. And so the one thing I want to leave you here before I pause for comments is, this is another example of the perils of not communicating risk. That if you're in the hurricane business, you've just got to shift to this risk-based approach, because I want to show you an example of Hurricane Laura. So the actual track is this purple line, and then the synthetic, this dash line over here is we basically lifted the hurricane up and moved it 20 miles to the west. So what would have happened if Laura would have moved west 20 miles? And then the colors here show the delta in storm surge, or the difference in storm surge between those two scenarios. And the bottom line here is if Laura would have moved west 20 miles, this area right in here would have gotten up to 15 more feet of storm surge. So this is, I think this is Holly Beach area. And then if you look up into the Lake Charles area, they would have gotten 5 to 10 more feet of storm surge. So think about that. That's barely a wobble. That's barely a shift. Hopefully the thunder is not coming through on it's storming pretty good here. That's nothing. 15 miles is such a wobble that it's, I don't know, maybe I need to coin a new word, the sub wobble. And yet it changed the storm surge outcome by 15 feet. And this is why we have to get away from this overly precise way of looking at hurricanes. You have to incorporate uncertainty, and you have to incorporate or adopt a risk mindset when looking at these particular storms. So I'm going to stop there, hopefully a little bit early to afford people a little bit of time and space to ask any questions if you have them.
Thanks, Jamie. I'll let you know if any questions pop up. I thought it was a really interesting point you made about the emergency managers. You know, they can't assume that they're going to have 3 days plus of lead time on preparations for a major storm. Yeah, because it has a huge impact on how they're able to respond.
Yeah, I mean, if you just do sort of anecdotal evidence of just me asking people around the country, you know, what's your typical hurricane plan, and it generally falls in the 3 to 5 day, meaning, you know, most people are assuming that they have 3 to 5 days notice. But imagine a case like Hurricane Michael, which, or even Ida for that matter, you know, it starts as a Category 1 hurricane, and overnight becomes a 4, or, you know, heaven forbid, a 5. You know, are you going to have time to react to that? And in many cases, hurricane planning and the way we exercise in this country does not assume that worst case scenario at all, anywhere close. And it's time that we start planning for and practicing for these shorter lead time systems, because increasingly in climate change, we're going to get rapid intensifiers more frequently, meaning storms that just abruptly intensify over a few hours versus a few days.
Cool, thank you. Yeah, we've got a couple of comments here. Mark Heister says, thank you for the explanation of your internal verification and falsifiability.
Yeah, we try to be as open and transparent as possible about our forecast process. I think we've always done that. Where we haven't done the greatest job in the past, because meteorologists are very humble, is we haven't done a great job of explaining how much better we are at forecasting than the junk you find on the internet. And that has just allowed people to, I think, gravitate to this sort of these spaghetti diagrams, or let me see what the models say, or that sort of stuff. And we're increasingly trying to help people understand that. I mean, think about it, if you came here and saw the nation's top hurricane forecasters looking on the internet, you'd probably be, you know, disappointed. We just have far better ways to poke and probe at the guidance, and we get more and better information than anything you can find online.
We have a question from Ranjan Motia. Can you describe services provided by Weather Prediction Center versus National Hurricane Center?
Yeah, great question. So first and foremost, WPC, or the Weather Prediction Center, is our service backup. So in the event that we were to, for whatever reason, the Hurricane Center lost communications or something like that, they would immediately activate service backup there and could issue the full suite of products that we normally would do. But I think the question was more pertaining to their routine products. They are the rainfall experts within the Weather Service. So when you see rainfall guidance coming from the Hurricane Center during a tropical cyclone, that information is coming from them. You know, so we see things like 5 to 10 inches or 10 to 15 inches, that information is coming from them. But more importantly, they issue this new product called the Excessive Rainfall Outlook, the ERO. And this product is not well adopted yet by the emergency management community, but it's an exceedingly good product, and it's becoming increasingly important as we get into these heavy, you know, I alluded to the storms that are coming wetter and climate change. That product is if I were you, I would rely on it as much as the cone. And if you don't know, they just expanded the ERO to 5 days for experimental applications this hurricane season. The first storm of the year was the disturbance that moved over Florida and ultimately became Alex. And they had us bullseyed in the 5-day ERO. And let me tell you, Miami got its clock cleaned by heavy rain. And they were able to identify that and advertise it 5 days in advance, which if you've been in forecasting long, heavy rainfall, lead times on heavy rainfall, that's a remarkable scientific advancement that has happened over the last, I would say, 5 years or so. So this excessive rainfall outlook issued by the WPC or Weather Prediction Center is, I would put it up there with the cone in terms of importance of what you should be looking at during a storm. Great question.
Question from Gizgithil. Is the National Hurricane Center running models to inform the National Hurricane Center forecast, or is it 100% from analysis?
Oh yeah. So we absolutely have all sorts of models, and some of them are run by other operational forecasting centers. Some of them are run by other countries, and some of them are run by us. We actually have our own models that we run internally that are not necessarily within the public domain that factor into the forecast process. So it's the forecasting is obviously partly analysis. The forecaster sits down and does an interpretation of the hurricane as it is it right then and there. And that analysis informs a component of the forecast, but not the entirety of the forecast. The forecast itself becomes mostly dependent on the guidance and models that we're looking at. But the more important thing is we're not looking at them in the way that they are presented online. That's an overly simplistic. The way they're presented online, or often in social media or some of these amateur websites, is a very I would say surface look at the models, that you really have to dive deeper to extract the useful information from them, and that's what we're doing. That's what our experts are doing here at the Hurricane Center. Good question.
James Howland says, congratulations on the new facility, and can you spend just a few moments recapitulating the new capability that the facility will bring?
You broke up just a little bit. I wasn't sure I heard it all. Can you repeat it, please?
Congratulations on the new facility. Can you spend just a few moments recapitulating the new capability the facility will bring?
Yeah, so prior to this particularly, this is not so much a new facility, but within the existing facility, we repurposed our library to create a lab within the Hurricane Center. And prior to this effort, we didn't have any place to host researchers or projects or experiments. So it was really impossible to test things in real time. We could only test things a lot in the off season, and then try to make the determination of whether it was ready for prime time. And often that led to projects being transitioned to operations prematurely, or they weren't successful once they were transitioned. We think with this new facility, let's go back to some more information here, we can provide a more realistic and difficult testing environment for promising research, and then isolate the projects that are most mature, most robust, and focus on them. And so if you've ever heard of the phrase research to operations, or transitioning the canyon from research to operations, that's basically the premise there. But also we want to take a more holistic view at research rather than just focusing on physical science research. Look at social, behavioral, and economic sciences, the so-called SBES, into the overall process. And by that, you not just create new, new products, new forecast products, or new warning products, but have social science on how people interpret or may interpret those products factor into the development process, so that when we do go out with a new project or new initiative or new product, it's more vetted and tested before it goes prime time. I think that's what you're asking, but if not, I can drill in a bit more on any one particular aspect.
Question from Jeff Brizendine. Is there a way to understand this rapid intensification and wrap that into our predictions?
The rapid intensification has historically been one of the harder nuts to crack within hurricane intensity forecasting. That said, we think within the last couple of years, we've finally started to make progress. And if you've been following along the last few seasons, there were some pretty remarkable forecasts from the Hurricane Center. I mean, the forecast for Ida, I remember saying, and I've been here for 23 seasons, I remember saying that's the boldest forecast I've ever seen, or the most remarkable forecast I've ever seen, because we explicitly forecast rapid intensification. And not only that, we did it on the first advisory. We just came out of the gates hot, if you will, which is very atypical of the Hurricane Center to do that. And then it verified. So we think we've gotten better and better at predicting rapid intensification. In terms of what you can do to anticipate it, it's hard because there's nothing out there in the public domain that would help one do it on their own. It's really coming from some of our internal guidance and, to be honest, forecaster experience. Computers beat up humans all the time, but this is one of the cases where I think humans still have a bit of an upper edge over the computer models. In some cases, it's just our forecasters know what to look for and apply that experience to the forecast process.
We have a question from Moore. How do you balance providing as much information to the public as possible versus the difficulty of explaining uncertainty? Flood warning systems see this issue often.
Oh, this is something near and dear to my heart. When I first started in storm surge, probably most of you know me from my time in storm surge. The notion of providing the public probabilistic information was, it was just the third rail of hurricanes. And, it was thought that the public couldn't understand anything, that they couldn't understand the threat, they couldn't understand risk products, they couldn't understand probabilities, they couldn't understand anything. And the reaction to that was to hide or withhold what I thought was an incredibly rich set of information regarding risk. I can remember 10 or 15 years ago, and if there's any EMs in the room, you know what I'm talking about, is there was this fear of communicating candidly to the public, that they just couldn't handle it. And I think over time, we learned that, as long as you put out risk products that have been properly vetted with communication experts and social scientists, and you take the time to explain it to people, that they understand it better and react more confidently to that information. I mean, this is, if we stop being so complicated with life, in any walk of life, if you're open and honest and transparent with people about the decisions you're making and why you're making them, there's a higher trust factor. And so why would we expect anything different with risk communication? If we're open and transparent with people over why we're uncertain about any given forecast or any given outcome, and express to them in odds, there's a 1 in 10 chance of this happening, or there's a 1 in 10 chance of this happening, but if it does occur, it's a life-altering or a life-threatening event. So therefore, even though the probabilities are low, we need to go ahead and take precaution, or we need to go ahead and take whatever action is necessary. People get it if you take the time. What happens is when people sloppily build probabilistic products or risk products without vetting them with communication experts in the social science, and just chunk it over the fence with little or no thought, then people don't get it at all, and it often results in less compliance or less understanding. So the key is to engage people who understand how to communicate. I've often said this, and the physical scientists in the room, give me the stink eye, but I'm referring to myself when I make this statement. Physical scientists are terrible communicators. And if you're offended by that, just take a moment to take it in. I'm including myself in that. I'm a physical scientist. I'm a terrible communicator by default. We're not designing products for ourselves. We're designing products for other people. So therefore, we must challenge ourselves to see the world through their eyes and not our own eyes. I'm not sure if that helps, but I can follow up if it didn't.
Question from Ben. Can you describe how the various river forecast centers access and use National Hurricane Center and Weather Prediction Center rainfall forecasts?
Yeah, that's a great question. So there's obviously you got the intersection of a lot of things going on here. So you got the surge coming up from the ocean and hitting the mouth of the river, and then the river is trying to flow into the ocean, and it can't because the storm surge has effectively plugged the river. And in some cases, the river will reverse, like the Mississippi River will reverse and go backwards. And then you got heavy rainfall, which is trying to go in the river, and the river is trying to go in the ocean, and none of it's going anywhere, and it just backs all up. So not surprisingly, those phenomenons all require different modeling approaches and different techniques. And so there's rainfall models, and then there are models that are run by the River Forecast Center that take that rain, push it through the catchment, push it into the river, and then try to discharge it into the ocean. And then I've got surge models down here. And so we have to couple those together during a storm. So if you look at any one product or one model, you could easily get an incomplete analysis of risk. Now, for the River Forecast Center, we provide them with the boundary conditions from the ocean storm surge, and they are able to merge that with the rainfall forecast from WPC, along with their own riverine models, to give you a holistic hydrograph, or what's called a total water hydrograph. So if you're getting information from the River Forecast Center, and in all likelihood, it includes that superpositioning of rain and risk that I just sort of outlined for you.
Question from do we remain on track for an above normal season this year?
Oh yeah, and if you're paying attention to the tropics, they're a little bit active for this time of year. Normally I would anticipate this level of activity maybe in July. So clearly the tropics are running hot, and all indications from a prediction standpoint is that will continue through the meat of the hurricane season. So I would be prepared for yet another active season, unfortunately.
And another question from Ben Pratt. Is there any indication of a shift in seasonality of type of hurricane season from recent climate science?
Oh yeah, that's actually a good question. So to help with context here, is there any reason to believe that hurricane season is starting earlier or ending later? Or is it the hurricane season going to start? Are we going to change the start date of the hurricane season? We've gone back and looked at this, and you know, if we would have changed the hurricane season from June 1 to May 15th, it would only encapsulate an additional 1% of the total activity. And that to me feels like a very small amount of, that's a very small benefit for a very large expenditure of time and resources to educate people on the change, you know, change from June 1 to May 15th. So as of right now, I would say no, there isn't a signal. That said, you know, when you're using historical information as a guide, sometimes the amount of data isn't, you don't have enough historical data to formulate a solid conclusion. And so, you know, as time marches on, we may find that that's not the case. But as of right now, it doesn't appear to be compelling evidence that the season is expanding in its start date or end date.
Question from Mutia. What ground truthing information and measurements is helping make your forecast better?
Oh my gosh, we have so many observations, it's hard to rattle them all off. And it expands and grows every year. So, I mean, there's a traditional observational systems, you know, buoys and ASOS stations, and then we augment it with damage assessments and high water marks. We partner with USGS to deploy sensors in advance of hurricanes. We have the aircraft, which we can, the Hurricane Hunter aircraft, which we can send in, and now we have sail drones, which are basically a drone that floats on the sea. We can send in. I mean, we have satellites, you know, satellite, not just the traditional satellites where you see the pretty images, you know, of how it looks, but we have satellites that can penetrate the hurricane a bit like a CAT scan might. We have the tail Doppler radar on some of our aircraft. Gosh, I've probably only routed off 25% of the observations, and in fact, that's a big part of the job for our forecasters, to sift through all that data and do it relatively quickly. Is you know, part of the reasons our forecasters are so good and beat everything out there is because they can very, very, very efficiently sift through all that information and make, you know, solid decisions, you know, often 10 or 15 minutes. You know, they don't get a ton of time to do that part of the forecast, but they're just so efficient at ripping through that information quickly. Great question, though. I never get asked about observations. That's sort of one of my passions.
Thanks, Jamie. And Ben Pratt says, thank you.
Oh, you're very welcome.
I'll give it about another minute or so for any other questions anyone might have.
As you're thinking about it, certainly you're always free to contact us. We're taxpayer funded. My salary is taxpayer money. So if we can be of assistance to you during a storm, reach out, you know, to our WCM, Dan Brown, or whoever, you know, you need to reach out to get in touch with us. We'll do our best to answer questions in the storm. I would say we have a decent track record to responding to things timely in a storm, but if there's a little bit of a delay during a storm, just know it's just because we're busy.
Where are you located?
Miami, Florida, on the campus of Florida International University.
Oh, okay. Ben Pratt says, tell us more about the sail drones, please. It sounds very slick.
Sail drone is relatively new technology. You've all heard of drones, and we experiment with those in aircraft in a storm as well. Even though we still most more heavily rely on human piloted aircraft, the bulk of our reconnaissance information. But more recently, we have drones that float on the ocean, sail drones, that can probe the hurricane at the surface. So our aircraft and drones can penetrate the hurricane, but they penetrate them at altitude, as you can imagine. For safety reasons, these aircraft often have to fly at a decent altitude, which tell us what's happening in the hurricane, but what's happening at the hurricane at altitude. So they're not giving us a direct measurement of what's happening inside the hurricane at the surface. The nice thing about the sail drone is you can direct them into the path of the hurricane, and since they're floating on the ocean, by default, they're probing the hurricane at the surface, which gives us very valuable information in areas that are often lacking. Thankfully, because our forecasts are so good, most of the ships at sea get out of the way of the storm, which means we don't have any surface observations from marine applications. And while we do have buoys out there, they're relatively rare. It's very hard for one to be hit by a hurricane. It's exceedingly rare for a hurricane to move over a buoy. So bottom line is we get very little surface information about the hurricane when it's out over water. And these sail drones are one way for us to close that gap.
Ben Pope says, thank you and go Pat.
His fellow NC State guy. So those who don't know, I'm a proud NC State graduate. So thank you for the comment.
Well, I think that about wraps up the questions. Thank you very much, Jamie, and appreciate your time today. And thank you everyone for joining us. Tomorrow, you should all receive, attendees will receive a follow-up email with a continuing education credit certificate. Thanks, everyone. Have a good day. Bye.